Okay, so we're talking about concavity, and the first thing we want to establish is definitions for concave down and concave up. We've already talked about increasing and decreasing. That's when the graph is going up from left to right or going down from left to right. All right, concavity talks about a different aspect of the graph. So the official definition of concave down is whenever secant lines are below the curve. Okay, so secant lines are lines that cut the curve at 2 points. All right, and so just to give you an idea, let's go over to the graph here. All right, and if I draw a line from any 2 points where it's concave down, cutting it at like so, right? This would be a secant line. The secant line is below the curve, so you can see here's the secant line, up above here is the curve. All right, so right there it's concave down. Okay, another way to think about this, and the way I sometimes mentally think about it, is it's where water would run off the graph. These are chunks of the graph where it would not hold water. Okay, so concave down would be over here until right about in here somewhere it changes. Okay, because it changes, and we can see because it switches to a point where right here on the graph, if you poured water in there, it would hold water. Okay, so there's a point at which that changes. We'll talk about that in a second. But this green would be concave down, the red would be concave up. Also, going on the secant definition that you have in front of you there, secant lines are above the curve when it's concave up, above and up, right? So if I draw a secant line across the curve here, the curve, you'll notice, is below the secant line. Okay, so those are the definitions of concave up and down. That'd be a good thing to have on your cardstock. All right, so let's flip back here. Okay, the point at which concavity changes is called the inflection point. All right, so the inflection point is that point that I kind of just briefly touched on there. So if this curve is down here, concave down there, concave up here, right, somewhere in here, and sometimes it's a little tough to see, but in calculus we'll talk about how to find that point exactly, but in pre-calc we're just going to kind of do our best to estimate it. All right, but somewhere in there it switches from being concave down to concave up. That's called an inflection point. Okay, so let's write for this first curve here. Let's label first the intervals of concave up and down, and then we'll write the intervals. Okay, so in green I'll take all the concave up parts. So I've got this part here that's already in green, right here. Right, and then in here it's concave up as well, and it's going to be concave up the rest of the graph. Okay, then in red, let's put the rest of the concave down. That's this chunk right here. Okay, so that is, those are the intervals of concave up and down. It's, and you might want to write this on your paper, it's up right here, excuse me, down right there. So down, wow, my penmanship's good. Down, up, down, and then up over here. Okay, and the next two we'll write out the intervals. So for that one, let's just label it. Okay, down, up, up. So let's look at the next curve. So the next curve here, I think on your notes is, just to be sure, is x plus 9 over x. Okay, so that's this blue curve. In fact, let's make it darker so you can see it better. All right, so what do we got going on here? Well, concave up. Oh, actually, let's start with concave down, I guess. Okay, so concave down. Remember, that's when secant lines, if I draw on a secant line, the curve is above the curve. All right, so it's concave down over here on the left, okay? And so we'll write that out, that interval out. So that's going to go from negative infinity up until you get to 0. There's a vertical asymptote here at 0. Okay, so it's going to be concave down everywhere to the left of the y-axis, not including 0. Okay, so that's where it's concave down. All right, then let's look at concave up. This other chunk of the graph here is concave up, right there. It's concave up, and we would write that it's concave up from 0 up to infinity. The rest of the graph is going to be concave up. Okay, there's no actual point of inflection here. All right, there's no point where it changes concavity. An inflection point is just that, it's a point. There is a change in concavity, but it doesn't happen at a point. So there's no inflection point in this graph. Right? Let's look at the next one then. Okay, this next graph here, I call it a volcano graph. All right, this is, once again, drawing in where it's up and down. So it's concave up here, all right, and it's also concave up here. Okay, so you can kind of imagine that it would kind of hold water, but you can always go back to the secant line definition. So if you draw in a secant line here, the curve is below the secant line, so it's concave up. Same thing on the other side. All right, so let's write the intervals on which it's concave up. Now the domain of this is only from -4 to the right of -4. Right, that curve stops at -4. So we'd say it's concave up from -4 up to 0, because notice on this one, again, there's a vertical asymptote right here. There can be no concavity at a vertical asymptote. Okay, so it's up from -4 to 0, and then picking up again at 0 to infinity. It's concave up. All right, so it's concave up on those intervals. Remember, no concavity at a vertical asymptote. All right, and it doesn't go to the left of -4. So that's the intervals in which it's concave up. So remember, concave up and down, you can always go back to those definitions with the secant lines if you're ever unsure. Sketch in a secant line and see if the curve is above or below it. Any point where there's a change in concavity, we call those inflection points.